In a previous video we talked about the conversion of volume. So when you're converting length you do it once. When you're converting area you do it twice. Okay, but when you're converting volume you actually do it 3 times. So 1, 2, 3. I'll just draw the rest of the picture so you can see what I'm talking about. Okay, so you're actually doing it 3 times. So if we're doing the same thing, millimeters cubed, centimeters cubed to meters cubed, okay, before when we went from millimeters to centimeters, okay, we divided by 10. If we were doing it in area, we divided it by 10 squared. If we're doing it by volume, we divide by 10 cubed. Okay, so centimeters to meters is normally divide by 100. For area, it's divide by 100 squared. For volume, it's divide by 100 cubed because you're doing it 3 times. And the converse is also true. Normally, you would times by 100, but since you were doing it in 3 dimensions, you do it 3 times, so you cube it. And normally you divide by 10. Sorry, multiply by 10. I don't know where I got divide by. You'd multiply by 10, and you would cube it. To work out the volume of a prism, you must be able to work out a, what's it called? A uniform cross section. So if, for example, and the book uses the same example, we had triangular prism, okay? To work out the volume of that, you would work out the area of this shape here, the triangle, because that runs the whole length, okay? And then you would multiply that by the length, okay? So the volume of any prism, as long as it has a uniform cross section of a prism, okay, is equal to, and I'll do it in colour, the area of shape multiplied by the length it goes. Is probably the best way to explain it. Okay, so the area of the shape is the cross section that runs all the way along it, times by how far that cross section goes. So for this one, it would be height, base, length. Now the area of a triangle is 1/2 base times height, and then that's going to be multiplied by the length. Okay, so it's quite easy to do. If you can remember those first formulas, those first area formulas, all you got to do is add another dimension to it. How far does that shape go? There are trickier ones to do, and if they don't have, what do you do if they don't have a standard area that runs the whole length of the shape? And some examples of that are pyramids. Excuse my dodgy drawing of a pyramid here. Okay, so this doesn't have one shape that runs the whole way through. So we need to be able to work out a formula for it. Okay, now the volume of any pyramid, so volume of pyramid, okay, is equal to 1/3 area of base multiplied by the height. Okay, so for example, for this one, let's say our height is there, okay, and this is a square based pyramid and all the sides are the same. So the area of the base, volume equals 1/3 the area of the base, which is L squared, times by the height, which is H. Okay, and that's the same for any pyramid. Okay, and I think that counts for cones as well. Okay, so if you had a cone rather than a pyramid, it's still a pyramid. Really, it's still a pyramid. Okay, you need to know the height and the radius. Okay, and the same formula will apply. 1/3 the area of the base, so 1/3 times by the area of the base, which is pi r squared, times by the height. Okay, so that simple rule there, volume of any pyramid is 1/3 the area of the base times the height, can be used for square pyramids, triangle pyramids, or even cones, or what we might call circular pyramids. What about the volume of a sphere? A sphere volume of a sphere. Okay, doing my dodgy sphere again. Alright, this is quite easy, surprisingly. It's the radius, okay, is the only dimension you need. The volume is equal to pi r cubed. Okay, simple as that. What happens when you have composite shapes though? The answer is it's very much the similar as area of composite shapes. The volume of any composite shape is equal to the volume of each shape. I can't spell today. Shape added together. Okay. So if you had a shape like this, okay, and then we decided we'd put a cylinder on the end of it, okay, and we might put a cone on the top of it, okay. The volume of that particular composite shape is just the volume of the rectangular prism, the volume of the cylinder, and the volume of the cone.